For this video, I'd like to talk about how to evaluate piecewise functions. So before we get into the evaluation, we need to ask ourselves, what is a piecewise function? And this is a function basically composed of multiple parts where that part is only covered over a certain part of the domain. So for instance, for all t values less than 6, the function looks like this. But once t gets between 6 and 12, it takes on a completely different form. This one right here, this is a quadratic. So it looks something like that. It's a parabola. This is a line with slope 5, 6. So that one's going to look something like that. And then once you get here, it again is a parabola, but now it's an upward facing parabola, anywhere that t is bigger than 12. So I'm not going to draw a very accurate graph here, but just to get some kind of idea of what might be going on, is that up until 6, you might have something maybe that looks like this, and it doesn't include 6, so I'm going to leave a hole there. Now this one does include 6, and so maybe this one starts up here, and then it's just a straight line all the way to 12, and it does include 12 for that line. And then once t is bigger than 12, now it's a parabola again, but it's an upward opening parabola. So again, I don't know exactly where it's going to be, but maybe it looks something like that. So this is an example of a piecewise function, where basically it's split off in different areas of the domain. So like for all x values between negative infinity and 6, it has this shape. For all x values between 6 and 12, it has this shape, and everything bigger than 12, it has this shape. So this is a way to join multiple functions together depending on how you want to split up this domain here. So with all that in mind, let's try and evaluate this. And we want to figure out what g of 12 is. Now, for actually solving these problems, the trickiest part is figuring out which of these three functions do you plug 12 into. And that's where we have to look at the domain. So t in this case is 12. So we need to figure out, where does t equals 12 fall in? Is it this one, or this one? It's obviously not this one, because that's t values less than 6. And this is for when t is bigger than 12, but not equal to 12. Notice this one has when t equals 12. So we're going to plug t equals 12 into this equation here. So we get 5, 6 times t, which is 12. And 12 over 6 is 2. 5 times 2 is 10. So evaluating this function at 12, you get a y value of 10. So 10 is our answer here. Now let's move on to another function here. So now we want f of minus 18. So with all of these, we just need to figure out which of these it falls into. Well, this one is for x values not negative 18, 36. Well, we have negative 18, so it's not going to be this one. This is when x is 36. Just at this one value, it's equal to this rational function here. And when x is negative 18, which is our case, it's equal to this linear function. So that's the one that we want, since x equals negative 18 is what we have. And so we fall on this domain. So we have negative 18. Let me rewrite that. Minus 6, all divided by 3. So that's minus 24 over 3, which is negative 8. So evaluating this piecewise function at negative 18, you get a value of negative 8. And let's keep going with these. We'll just do a lot of practice. So now we want f of minus 10. So we need to figure out which of these domains includes negative 10. So you might think this one, but notice you don't have the equal sign there. So this is all values that are bigger than minus 10. But this one includes negative 10. So we're going to use this equation here. So we're going to plug in negative 10 to t squared. So we have minus 10 squared, and then we have minus 5 times t, which is, again, negative 10. Minus 10 times minus 10 is positive 100. And then we have minus 5 times minus 10, that would be plus 50. And so evaluating this piecewise function at negative 10, you get a y value of 150. And continuing on. So now we're getting into interval notation. So it's a little bit harder to read these, but ultimately it's not too bad. So h of minus 3. And again, we need to figure out, where does it fall? Which of these domains includes negative 3? So using this interval notation, basically it starts with, let me use brackets first, the lowest value, and then it goes to the highest value. So let's say you had something like 0 to 8. All right, and again, I'm using brackets. They are different from the parentheses, and I'll clarify that in a moment. This is the same thing as all x values between 8 and 0. So this here basically means its lowest value is minus infinity, and its highest value is 0. So this part of the domain basically covers all negative values. And if you want to write it using this notation with inequalities, you can do this as well, just to kind of help yourself out. And this one right here, notice the parentheses. So if I have something like 3 to 5, the parentheses mean that these points are not included. This is still the lowest point, but now x can't actually equal 3, and it can't actually equal 5. It's between them, but it's not equal to them. Whereas if these were brackets, then you would put the equal sign underneath. So that's the difference between brackets and parentheses. Brackets include that point, parentheses do not. So h of minus 3, we need to figure out which of these intervals negative 3 would fall in the middle of. Well, this is all values from 8, not including 8, all the way to infinity. And by the way, you can never include infinity. Infinity is never going to have a bracket because it's not a number, it's a concept. And this one here would be x values less than or equal to 8, because it has a bracket, but bigger than 0, because 0 is included in this one. So our negative 3 is going to fall in the middle of minus infinity and 0. And so we're going to use this function here. So we have minus 3, and we're going to cube it. So that's minus 3 multiplied 3 times. And these two will pair up and cancel out the negatives, so you get 9 times minus 3, and your final answer would be minus 27. So be careful with this interval notation. It might be new to you, but for a class like college algebra or a more advanced math class, this interval notation tends to be used a little bit more than the inequality notation. So it's definitely something you want to be familiar with.